what we're going to do is put the slurry wall in. Because what happened in reality was they did the initial model that had that factor of safety of 1.1. They put the slurry wall in, and they got a factor of safety of like 0.99 or something less than 1. And so they said, okay, this is really questionable because we actually did this and it's still standing. So this was really the motivation for doing this. We know that putting that slurry wall in is going to reduce the factor of safety. How much does it actually reduce it? Is it going to be safe? So all we need to do now, let's make a new file. I'm going to go new data file. Let's call it slurry. I'm going to start with restoring that undrained case, model restore, undrained, whatever you called it, when we changed the cohesions and we solved it, but before we did the factor of safety. Now here, it's just I'm going to actually give it a group name by hand with commands. Zone group slurry range pause x. Remember we drew a line at 170 and a line at 172. So I'm going to say between x 170 and 172 and y between -10 and 2. Remember we drew a horizontal line at -10. Now in theory what I should have done was identified this little region in the sketch pane and gave it a group name, or in the model pane and gave it a group name. Could have done that. But let's pretend I forgot. And so now I can just do it by hand with a command. Actually, the reason I didn't do it in the, I'll tell you why it's done this way. In the sketch pane, when you assign properties to things, they always go in that construction slot. So I identified the clay layer, the sand layer, the waste layer, and the rock layer. The slurry wall cuts through all those things. So if I just clicked on that section between 170 and 172 and called it slurry, it's going to overwrite the names that I already assigned, the clay and the rock and the waste, which is going to mess up my material properties and everything else. What I really want to do is have that slurry group name in a different slot. And in the sketch, we do not yet have the ability to specify different slots for different groups. That's coming. For now, we don't have that. It always goes into that construction slot. You have no control over it. So I couldn't assign that slurry group because it's going to overwrite my geological names. So what I have to do here instead is give it with a command. And if I don't give a slot name here, it just goes into the default slot, which is different from the construction slot that the sketch uses. So I'm not overwriting the names that I already assigned. I could be more specific here. I could give it a slot name, slot, something. But I know that it's just going to go into slot default and everything's going to work. Okay. Yeah, okay. Let's just do that. So now what we need to do is just give different properties to this slurry wall. So I'm going to say zone prop. It's still going to be more Coulomb material. I don't need to change the constitutive model. I could. That's not. So I'm just going to give it new properties. Density 1000, bulk 4.8 E3, shear 1.4 E3. And if I don't type anything else, it defaults to 0. So this is presumably some gooey, horrible material with basically no strength. And so I don't type in anything here. It's basically got 0 cohesion and 0 friction. You may or may not want to actually type that in. So when you come back in the future to see what you were doing, you could say, oh, I actually meant to put in 0 cohesion and 0 friction, and it wasn't a mistake, and then I just forgot to type it. You know what I mean? If I don't type it, it defaults to 0. But then your future self will come back and say, oh, heck, was it supposed to be 0, or did I just miss it? You know what I mean? So even though it defaults to 0, it's often not a bad idea to actually manually type it in to say to yourself, oh, I actually meant that to be 0. And not, I just forgot. Now I only want this to happen on the slurry wall, so I can say range group slurry. And the other thing we're doing here, so presumably what happened in real life was they actually excavated this thing and filled it up with this horrible gooey material, which means that this little slot doesn't have any stress associated with it, right? So you can just zero the stresses in there by doing something like this, zone any stress. I think I can just give the components of stress here, but let me just check. Zone any stress. No, I have to do it component by component. That's fine. And so I can do it like this. Zone any stress, XX 0, XY 0, YY 0, ZZ 0. Remember that even though in 2D there's a ZZ stress. Range, group, slurry, right? We're only initializing 0 stress in that little slot. So I essentially hunked out this little 2-meter piece of material, filled it up with some gooey stuff. Stress is now 0. And now I can do a factor of safety analysis. And we can expect, I'm just lazy here, so I'm just going to type F-O-S. And just to be specific, I could say file name slurry. So that when it makes these files automatically here, it has a sensible name instead of FOS init 02 and FOS stable 02 and so on. Okay, so we would expect this to probably reduce the factor of safety because we've got this gooey, horrible material at the toe of the slope. Let's just see what happens. In theory, this might also change the pore pressure distribution. Presumably, the whole point of the slurry wall is to do something with the pore pressures, but you can assume for now that we're going to use the same pore pressures. If I run this thing, I get a factor of safety of 1.27. If I double click on the unstable case in my save states, go back to my zone plot. All right, so I'm going to go to my cohesion plot here and click the little circle next to range. So I'm not using that range anymore. Basically, ignores the range that I set up. And I'm going to change my contour to velocity. Now I can see something quite different here. I'm getting super high velocities right at the top of this wall. Presumably it's like squirting out the top here. If I put my vectors back on, the opposite. It's just getting squashed. If you want to possibly a better plot of the failure surface, remember we did this in the factor of safety section. If I go to my plot, click on zone velocity plot, change the zone value to strain rate, change the quantity to maximum shear. It still looks kind of wacky. Presumably this squidgy layer here is just deforming massively and messing everything up. But anyway, you get the idea. Got a factor of safety of 1.27, which is quite a bit less than we had without the slurry wall, but still quite a bit more than we had before we messed with those cohesion properties. So my understanding is that when they actually did this project, the client was quite happy with this number, and that was basically the end of it. So, any questions about that? We change these contours to make this more obvious what's going on here. If I go into contour, and for the maximum, I choose, I don't know, 0.0005, 0.00001. Oh, there we go. I made my maximum 0.0001. I can kind of get a better picture of what's happening. The problem is that there was a huge amount of displacement right at the top of this slurry wall, which was messing everything up. Probably zero friction is not exactly correct. Zero cohesion, but anyway. There's a bunch of random topics that are fun to talk about. So, okay, let's pretend. Let's double click. Okay, take this plot, change the contour to show pore pressures. Oh, and then let the contours have an auto maximum and auto minimum. Hopefully you see a lot like that. You can hide the factor of safety entry. And what we can do here, just to make it a little bit more interesting, is we can actually plot the histories on top of this thing. So go to the plus in the plot item list, or the little drop down there, and choose history chart. And then click the plus next to the 1, the 2, and the 3. So essentially, we're plotting the pore pressures on top of the model. And you can see here, it's magically, the colors match. So history number 1 is this light blue line, which matches the light blue square. History number 2 is the green line, which matches the green square. And history number 3 is the red line, which matches the red, where the red square is. So that's kind of cool. You can actually change these colors by hand if you want to. You want to probably change this axis. This title is not very informative, axis 2. So if you're in your history plot and you go down in the attributes where it says axis 2, you can expand that. And where it says label axis 2, you can overwrite that and just type in pore pressure. You can even force it to use an exponent of your choosing. It automatically is plotting these times 10 to the minus, sorry, times 10 to the 4. Maybe you like to think of things in kilopascals. So you can uncheck that where it says auto and change that value to 3. So now it's plotting the pore pressures as some number times 10 to the 3. These are essentially kilopascals now, right? So what we're going to do here is just rerun the fluid analysis, but we're going to make a movie and watch this thing go. In this case, it's not super exciting. It's more fun when you're doing these dynamic analysis and you have waves propagating through. But just to illustrate the point. So if you go to tools, wait, first of all, let's get a feeling for how long this took how many steps this was. So I'm going to go to my save states, and I'm going to double click on fluid.save. And it ran for 200,000 cycles. So let's say I want 100 movie frames. I want to take a snapshot every 200 steps. Is that right? Did I do that math right in my head? 2,000? 2,000. 2,000. Okay. So I go to tools, go to options, and click on movie. Oh, I need to be actually looking at the plot. So cancel that. Go back to my zone plot here. Now go to tools, options, movie. And at the top it says movie interval. I can change that to 2,000. And specify some image size. And then I click which plot I want to make a movie of, and then my choice is zone. It's the one that's visible. You can imagine if you have a split screen, you might have multiple plots, but in this case, I've only got one. And so what it's going to do is every 2,000 steps, it's going to dump out a PNG file of this size with the name movie underscore, and it's going to increase the number. So movie 1, movie 2, movie 3, movie 4. We're going to end up with movie 100 at the end. So I say OK. Now if I go back to my fluid.dat file, and I run it, in theory, it should be making multiple plots. I don't know if I actually have to be looking at the plot for this to work. I'm going to go into the file location where this model lives, which is training FLAC2D A3 landfill. Okay, that's totally not working. So presumably, okay, I'm going to stop that. Presumably, I need to actually be looking at the plot for this to work. So I want to split my screen here. I'm going to show the zone plot on the right-hand side. I'm going to run that fluid again. I'm just going to double check that everything's still set up here. All right. So now I've got the zone plot visible. I'm going to run that fluid again. I'm going to check this making movie frames. Oh, here they come. So now I'm looking in my directory here. I've got movie zones 01, 02, 03, 04, and so on. So once you have all the frames, you can do whatever you want. Dave D, who did the fish yesterday, he says you can make these movies actually in PowerPoint. Apparently you can do that. What I do is use the Windows Movie Maker. So if I go into the Windows search bar and I just type video, it comes up with video editor. Make a new video project. Whatever you want. I can add photos. So I choose from this PC. I go and find where all those PNGs are going. And I just select them all, or all so far. And I say place in storyboard. And now by default, it makes a movie for me with 3 seconds between every frame, which is not very satisfying because I end up with a 2-minute and 18-second movie of something that's not changing very fast. So I click down here in the storyboard and hit Control A to select all of the plots. And then click duration. I can change it to like 0.2 seconds or something. Now I've got a 9-second movie, so I can just hit play here, watch my movie. And then I can say finish video and saves it as a before. There you go. So that's kind of fun. You don't have to use the video editor of Windows, but the exercise of dumping all those PNGs out automatically is kind of useful. Again, more useful for dynamic analysis, but you can still do stuff like this. You go back to your plot. I'm sure you already talked about the fact that when you hang your mouse over here, you can see information down in the bottom right corner. So it's telling me the value, what zone I'm in, what group I'm in, things like that, right? Let's hide the history chart. So I've only got my zones. Oops. So now I'm getting information about what zone I'm in, what group I'm in, what value is, so on. Let's pretend for whatever reason you wanted some super detailed information about one of these zones. Maybe one of them looked bad or something. I can click on this little arrow with the question mark here at the top, and then click on one of these zones. And it actually says, oh, do you want information about the zone or the grid point? So I say zone. So now I get all the information I could ever want about that zone. Location, properties, stress, so on. And it also has little links here to the grid points. So every zone here is made up of 4 grid points. So I can click on one of them and get all of the information about that grid point. And then position, displacement, so on. And then the grid point actually tells me which zones it's linked to. So I could click on one of these and find out more information about the zones it's linked to, and so on. Or I could just go back to the zone I was looking at, this little back thing. So this is mostly useful for like debugging, but potentially kind of cool. And you can actually just take it and copy to the clipboard if you needed to output all the stresses and properties or whatever you want. So that's kind of a fun tip.